gadgets are getting smarter all the time, doing some really impressive stuff right there on the device.
Yeah, it's true. And a lot of the buzz lately is around the engine making that happen, the NPU, the neural processing unit.
Exactly. So for this deep dive, we really want to get clear on what an NPU actually is and, maybe more importantly, how it's different from a GPU, the graphics processing unit.
Right. Because understanding that difference is, well, it's pretty key to figuring out where our tech is headed.
Definitely. We've got some good material here that kind of breaks down these processors.
It's interesting when you look at the evolution, right? You had the CPU, the workhorse, good all around.
The brain, basically.
Yeah, the main brain. Then came the GPU, fantastic for doing lots of things at once, parallel stuff, initially for graphics.
Making games look good.
Making games look good, exactly. But now the NPU is like this hyper-specialized little brain.
Okay.
Its whole job is speeding up AI tasks, image recognition, understanding voice commands, sensor stuff right on your phone or laptop locally.
Right. So it's a chip specifically for AI built into our devices.
Yeah.
And that means faster responses.
Faster responses, yeah. And better privacy, because the data doesn't always have to go to the cloud. Plus, lower power consumption.
That's huge for mobile devices, like having a dedicated AI copilot that doesn't drain your battery.
That's a good way to put it. Historically, the CPU, it's flexible, but it kind of struggles with the sheer volume of repetitive math in AI.
Like neural networks.
Exactly, those endless multiplications and additions. GPUs are better because of their parallel nature, but NPUs, they are built, architected from the ground up just for that type of math.
Okay, so what's special about the architecture? What are the key ingredients of an NPU?
Well, there are a few core things. First, they tend to have a massive number of very simple processing units working together in parallel.
Like a huge team doing simple jobs simultaneously.
Sort of, yeah. They also need lots of memory placed really close by for fast access, and a high-speed cache for data they use often.
Makes sense.
And here's a really crucial bit. NPUs often work with lower numerical precision.
Lower precision. That sounds bad. Why would less precision be good?
Yeah, that sounds counterintuitive. But think about GPUs, they need a high precision, like 32-bit floating point numbers.
For graphics, right. Getting light and shadows perfect.
Precisely. Tiny errors there are noticeable, but for many AI tasks, like recognizing if a picture contains a cat or a dog, you don't necessarily need that extreme precision.
Oh.
So NPUs can often get away with using, say, 8-bit integers in 8. This drastically cuts down on the memory needed and the energy used for calculations. It's way more efficient for the job.
Got it. So the GPU is this powerful, versatile beast. Graphics, gaming, even high-end AI training.
Right. It can do a lot.
But that versatility means its internal circuitry is more complex, even when it's just doing relatively simple AI math compared to, like, rendering a whole 3D world.
Exactly. The NPU strips away all that extra complexity. It's laser focused on accelerating those core AI operations fast and efficiently.
Can we refine that analogy you mentioned? The briefcase versus the notebook.
Oh, right. Yeah, think of a GPU tackling some typical on-device AI math, like carrying just a single notebook inside a huge, heavy briefcase.
It works, but it's bulky and inefficient for just that one item.
Exactly. The NPU is like just carrying the notebook itself.
Yeah.
Perfectly sized, lightweight, super efficient for that specific task.
Okay, that clicks.
Yeah.
And that efficiency, that low power draw, is that why NPUs really took off in smartphones first?
Absolutely. For things like, hey, Siri, or, oh, okay, Google detection, tracking your steps, maybe crash detection.
Stuff that needs to be running quietly in the background without killing the battery.
That's the sweet spot. These lighter, often always-on AI tasks are perfect for the NPU's low energy profile. Now, for really heavy lifting, playing a demanding 3D game, or actually training a big AI model, you still need the raw horsepower of a GPU.
Right. Different tools for different jobs.
And that said it better.
Oh, quick summary then.
Yeah.
GPU gives you maximum power, very versatile, but uses more energy. NPU is super efficient, specifically for AI tasks, much lower energy use, but specialized.
That's the core distinction. And looking ahead, as AI gets woven more deeply into everything we use,
which it seems to be doing daily.
right, the NPU will be that silent partner making our devices smarter, more responsive, more efficient, often without us even realizing it's there doing the work.
So the big takeaway here is that NPUs are these specialized engines really driving the future of on-device AI, bringing efficiency that fundamentally changes how our tech works day to day.
Absolutely.
Okay, here's something to chew on then. As these NPUs keep getting more powerful, what kind of completely new AI features might we start seeing baked into our phones, our laptops, maybe even our cars? And how could that change how we interact with technology down the line? Something to think about.